Okay, good afternoon. Our project is interactive tactile maps. So I will just go over an introduction to our project and a quick overview of our implementation before we move on to the demo. So tactile maps are accessible maps with raised protruded surfaces so that visually impaired people can use them. So it has been shown both through extensive use and research that this is an extremely helpful tool for visually impaired people. Uh, but there are a few common drawbacks. Tactile maps generally require industrial level manufacturing, so cost is generally an issue. Design, you require to generate complex 3D models which require software and extensive knowledge, so that is generally an issue. And maps like these are generally static when used by themselves. So users lack interactive feedback, and that's something we hope to address in our implementation. So just a quick overview of some existing alternatives. Braille displays, tactile tablets exist in the market, but as of today, they are very expensive. For example, the cheapest braille display you can get out there is $7,000. The cheapest tactile tablet is $800. What we want to address with our implementation is cheap fabrication using 3D printers, an accessible web tool to allow users to easily create maps of areas they would like to explore, and a companion Android app to go with the map to provide interactive feedback. So I'll before we move on to the demo, I'll just go over the process we would like our users to go through. So the user logs into our server, securely creates his map, marks points of interest on that map according to the areas he would like to investigate, clicks a button, generates a 3D model of the map. This can then be printed out and paired with an NFC sticker to indicate to the application which map is being currently used. And post that, you just simply pair it with your Android app, which looks like this, and it works out of the box. So we'll move on to a demo where this will be all much clearer. So for our demo, we're going to screencast an image of the phone while we use the app physically itself. So our user wants to go from Shadyside Presbyterian Church to Hamburg Hall. So he picks out the relevant map, he taps it. So as you can see, the corresponding map is generated on the app, and the user simply inserts it into the case, and this is all the setup he needs. Now he wishes to. So we're going to be simulating the GPS movement for our demo, and we're going to allow, currently the user's GPS location has been simulated at Shadyside Presbyterian Church. So we will now go through the process of setting the destination and source.
Please select the starting point. Neville at Bayard. Source set to Shadyside Presbyterian Church. Please select the destination point. Please tap again to select Hamburg Hall as your destination. Destination set to Hamburg Hall.
And we,
Westminster Place. Distance is 495 feet and duration is 2 minutes.
this is part of the vocal feedback we give users. We let them know how much they need to walk and what direction they need to walk, how much time it will take, and we also inform them of nearby bus stops as and when they pass them, so that they can cancel their route and get onto a bus if needed. Currently, we are simulating the GPS movement of the user from Shadyside Presbyterian Church to Hamburg Hall, and I'll just move the mic towards the phone so that we can see what sort of vocal cues we're getting.
Approaching bus stop Amberson Avenue at 5th. Approaching bus stop 5th Avenue at Amberson. Turn right onto 5th Avenue. Distance is 0.2 miles and duration is 3 minutes. Approaching bus stop 5th Avenue opposite Amberson.
So that was an example of part of the path of the walk to Hamburg Hall. We'll quickly cut to the grid map and which the user wanted to explore in detail. So we will now simulate the user's interaction with the grid map. So he has entered a location he would like to investigate, and the app has informed him of this. This is the user now removes the map and taps the map corresponding to the grid map and inserts it into the case. He can now explore this area in depth.
Please select the starting point. North Oakland. Source set to grid, Luca Ristorante and Wine Bar. Please select the destination point. Please tap again to select Psychotherapy Referral Services as your destination. Destination set to Psychotherapy Referral Services.
Uh,
Street toward Winthrop Street. Distance is 135 feet and duration is 1 min. Approaching bus stop Craig Street at PGH Blind Association, Craig Street at Winthrop Blind Association. Turn left onto Winthrop St. Destination will be on the right. Distance is 115 feet and duration is 1 min. Arrived at your destination.